Okay guys, hello. We're going to be learning today how to take negative square roots, okay? Usually, you cannot get a negative square root with real numbers, okay? But we're going to learn how to do it today using the imaginary number I, okay? And we're going to use this definition that I squared equals negative 1, okay? I squared equals negative 1. That's the definition of the imaginary number. Now, usually before, in all the numbers that we've used, the real numbers, okay, if you square them, if you square a positive number, you get a positive number. And if you square a negative number, you get a positive number again. So the imaginary number is a number some mathematicians imagined. And they imagined that it could be equal to negative 1. This number helps us solve a lot of problems, all right? This being one of them. How do you find a negative square root, okay? Well, let's talk about it for a second. If I squared equals negative 1, what's negative I squared equal? Alright, so let's do that. Negative I squared, alright? Well, that equals negative 1 times I squared, right? And negative 1 times I squared equals negative 1 squared times I squared. But what's negative 1 squared? It's just 1. But what's I squared over here? Well, I squared is negative 1. So we have 1 times negative 1. And what's that make? It makes negative 1. So really, we see not only does I squared equal negative 1, but negative I squared equals negative 1. Okay? So we can be sure that plus or minus I squared equals negative 1, okay? So we have to know about how to use both of those, all right? So let's check it out. Let's do this problem the way we usually do it, all right? Well, if I take the square root of both sides right here and take the square root of this side, then I see plus or minus I equals the square root of negative 1. So we just break open the square root. Okay, 144, we factor it the way we usually factor them, right? 12 times 12. You want to get a number that repeats, okay? And then, well, 12 times 12 times negative 1. And it must have been negative 1 because that's a negative 144. So anytime that two things appear underneath the square root, you're going to take out one of them. So we know this equals 12 times the square root of negative 1, okay? But what did we just see? The square root of negative 1 equals plus or minus I. So really, this is 12 times plus or minus I, alright? And that's probably not the best way to write it. The best way to write it would be to put the plus and minus in front of everything. So we got plus or minus 12I, alright? And we're saying that this is the square root of that. Let's double check this because it's been, this is the first time that we're using these numbers. So let's really check it, okay? So here we go. We said it was 12I, so let's see what 12I is when you do 12I times 12I. Well, I get 12 times 12, and I get I times I. 12 times 12 is 144, and I times I is I squared. But what's our definition of I squared? I squared equals negative 1. So we know that this equals 144 times negative 1. And 144 times negative 1 is just negative 144. Alright? So we know we have one of the square roots. If I multiply this number, 12I, times itself, I get negative 144. So that's why this is the square root of negative 144, okay? 12I is one of them. Let's try negative 12I now, just to make sure that our plus and minus theory is correct. So we got negative 12 times negative 12, and that's times I, right? We just rearranged the order of the numbers. So negative 12 times negative 12 makes positive 144, all right? And what is I times I? Well, we all know that's I squared. And we've been studying today how I squared equals what? It equals negative 1. So we have 144 times negative 1. and that means that we have negative 144, okay? So, if you see the pattern that's going on here, right, we could talk about this for a while, but it's really not that complicated, okay? The square root of 144 is 12. That's obvious, right? We've known that for a few years now. But if you have a negative in front, then all you have to do is put an I in the back and make sure you do plus or minus, okay? So let's see how this would work on our next one, and we'll try it out to make sure we got it right. So, by the pattern that I just showed you guys, all right, the square root of negative 64 is plus or minus 8i. Because like we said, you just take the square root of that and put it there. Since it's negative, you have to have an I, and just don't forget the plus or minus, all right? Let's work this out and make sure it works. So 8i times 8i equals 8 times 8, that's 64, times I squared. I squared is negative 1. So that's 64 times negative 1, and that is negative 64. So if you multiply 8i times itself, you get negative 64. That's why it's one of the square roots, okay? We're going to see right now, we're going to check actually to see if the negative one is also a valid square root. So we're going to do minus 8i times minus 8i. And you're going to get minus 8 times minus 8. That's going to make positive 64 again. And then we're going to get I times I, and that's I squared. And like we've been studying today, I squared is negative 1, and negative 1 times 64 is negative 64. So hopefully you can believe me now that this pattern is going to work. If you just take the square root of that and put it right here, all right? If you take the square root, all right, don't forget your plus and minuses right here, all right? You need your plus and minuses, and please put the I at the end, and that's going to make sure that you get negative, and the plus or minus covers both of them, okay? So the final answer is the square root of 64 equals plus or minus 8i, all right? So, let's try it again, all right? You start out by putting, this is a negative, so we're going to have plus or minus, all right? And then we have to put the square root of 100. Square root of 100 is 10. And then since there's a negative, just remember to put the I. And then the problem is over. Alright guys? That's the way that you should probably be able to do this kind of quick. Alright? Because they're not too different from the old square roots that we used to do in Algebra 1 and stuff. Okay? All you have to do is add the I and the plus or minus, and then you have the right answer. So I'm going to give you guys this one to do for exercise to practice right now. And I'm going to go ahead and wait here while you guys work. All right, go ahead, work, scribble. And are you done? I hope so. Get the pen working. So, like I said, put your plus or minus. All right, the square root of 81 is 9. And then don't forget to put the I. That's your answer for this one, all right? 9i times negative 9i. Now, if you don't believe me that this is going to make negative 81, and you want to get a little extra practice with this to see how these work, go ahead, multiply 9i times itself, and multiply negative 9i times negative 9i, and you're going to check to see if these equal what? You're going to check to see if they equal 81, okay? Negative 81. So multiply those out and try it if you want to verify for yourself that they are in fact square roots of negative 81. Alright, so here we go. We have a little more to do. So the new thing that we're going to try is called grafting complex numbers, okay? So we saw about the imaginary number. This is called the imaginary axis now, okay? So we're graphing complex numbers. It's not that different from XY coordinates. It's really not that different, okay? This is going to work the same. Once you get the hang of this, you're going to feel like you're just plotting a point because, in fact, that's all you're really doing. You're just plotting a point for these problems, okay? So, complex numbers are written of the form x plus yi, okay? This number right here, x, is called the real part, all right? And the y is called the imaginary part. So, whatever number you have for the first coordinate is going to be the x coordinate. So the number that we have here is the x coordinate of our point. So I have negative 3 for x, all right? And the one that comes with the I, that's your y coordinate. So my y-coordinate is positive 4. So all you have to do is make sure that you look at the right axis, okay? This first number is the real number, that's x. So you can still treat the real like it's x, and you can still treat the imaginary like it's y, as long as you remember we're in the complex plane now, okay? Graphing this is going to work exactly the same as it did when these were x and y, all right? So you go to negative 3, right? And we see we have to go up to 4. So you just go 3, and y is 4. And that's literally the end of the problem. There's nothing else to do now. You have to put down the coordinates by grabbing them from there, right? And we got the positive 4 right there like that, all right? We have to practice another one for you guys to get the hang of it. So check out this one. All right, like I said, we have x plus yi, and we have 5 plus 2i. So what's x? X is 5. What's y? Y is 2. So I go to 5 on x and 2 on y. And the problem's over, right? This is 2. This is 5, right? So there you go. The problem's over, just like that. You have to graph the points down where they go, okay? I'm going to give you guys a couple of exercises to practice. So let's try this one. Let's see what you guys think this one is, okay? Go ahead. I'm going to give you guys a break. You try to graph it, and then we'll meet up in a couple seconds and see what you get. Hit pause, huh? And let's see if you got it, okay? You got x plus yi. And our number that we have is 5i, all right? So we're trying to get our coordinates, but it looks like there is no x, all right? So really, that means that it's 0, all right? If there's no number, if there's no real quantity, then it's 0. It's non-existent. And for y, we have 5. So this says that x is 0, but I have to go up to y equals 5 to plot the point, okay? So that's where you graph the point, 5i. That's the way you graph it, all right? Let's try the next one. So you have 4 minus 4i. We're going to write it again, x plus yi. And we're going to write 4 minus 4i underneath. And we're going to try to break down our coordinates, okay? This is a positive 4, so this is positive, but this one's negative, right? So you actually have to write the y coordinate as negative if that's a minus, okay? So make sure that you go to 4 for x, but y is negative 4. So I don't go up. I have to go down to negative 4 to plot my point, all right? You guys got a few problems like this to check on the practice final, so definitely practice graphing some of these, all right? They're not so hard. There's a couple problems on the test where you have to do this. If you guys practice writing like that and writing the number right underneath it, you can't go wrong, because all you're really doing is copying the numbers straight down into these boxes, okay? So try that method, and you should have a pretty high accuracy, all right, guys? Let's see what the next kind of problem I had was, all right? Now we're going to practice simplifying complex numbers, expressions with complex numbers. It's not that different. It works just like a variable, right? So if I have x plus 2x, then I got 4x, right? It works the same way. I is kind of like a variable, so you can just add it up with other like terms, other things that have I in there, all right? So let's write out this number sentence all as one thing. We got negative 7 plus 2 minus 4i, and then we got to add 2i. So negative 7 plus 2 is minus 5, and minus 4 plus 2i is minus 2i. So all you do, like I said, is combine the like terms, all right? That's it. The numbers go with the numbers, all right? Those constants have to add with each other, but the ones with I, you just have to combine the coefficients and you'll be good, all right? So if you follow me to number 30, we could practice another one, all right? So we have 5 plus 5, and then minus 4i plus 8i. So what's 5 plus 5? That's 10, right? But minus 4i plus 8i, that's going to leave us with positive 4i. Alright, so like I said again, all we're doing is combining these like terms, and I'm combining the i's with the i's. So negative 4i plus 8i, alright, is going to leave us with 4 i's left over. The same way that all variables subtracted and multiplied and whatnot, alright? That's all you have to do. So now, I want you guys to try this one on your own for a second. even though this one has not many operations with complex. All right, go ahead and pause and make sure you get this one right. We'll try one more. All right, you got it? Let's see if you got it. So we got 5 plus 3i. Oh, messed up in row 3. We got 5 plus 3i minus 6 minus 4. That's really minus 10. All right? And so if I reorganize this, that's 5 minus 10 plus 3i. And 5 minus 10 is negative 5. We have negative 5 plus 3i, all right? So just make sure that you follow the order of operations the right way. This didn't have us had to combine any i's, so just make sure that in this problem you don't write something like 8i or something. You can't combine the I with a number if it doesn't have an I, all right? Let's see this one. Cool. So go ahead, hit pause. Try this one on your own. I'll wait for you. Let's see how you do. And let's go. You got negative 3 minus 4. And then you have positive 8i plus I. So let's just put minus 3 minus 4. That's minus 7. And 8i plus I is 9i. All right, I hope that's what you got. This concludes our lesson on complex numbers. There's a little more stuff we could cover on here, but, you know, for the final, this should be enough for you guys to review for that test. All right, so good luck, you guys. Study.